The next topic is to talk about how to index a vector after you have created it. And what I mean by indexing is how you get access to particular elements of the vector in terms of individual elements or groups of elements of those vectors. Oftentimes when you're doing math with variables in R, you're not working with the whole vector at once. You want to get pieces of it to work with. Now the trick with R is there's many different ways to do that. So this is one of the things that makes R a little bit more confusing to learn. It gives you a lot of flexibility and power in that there's many ways to do indexing, but that also adds complexity and really understanding how the code works. So I think this is another one of those topics where it makes sense to spend a little bit of extra time when you're first learning R, learning some of the details of how indexing works and how the variable ways of doing it work. So the first way I want to talk about is how to use numerical indexing. And that's basically saying which numerical element are you talking about? The first element, the fifth element, the 10th element? Numerically, how do you recognize those? Or how do you designate those? We do that by using square brackets immediately after the variable name. And one thing to note about the numbering of the elements is that by default in R, the numbers start at 1. So the first element has an index of 1. That's different from a lot of languages where that first element will have an index of 0. So if you're coming from another language, that's an important difference to recognize. So if we go back to an R session, let's say we want to create an atomic vector of integers that goes from 11 to 20. So if we look at that vector we just created, it starts at 11, goes to 20, and increments by 1. Just as we would expect for the colon operator, we can check our type and see that it is indeed an integer, which we would expect for the colon operator. It assumes an integer when you put whole numbers in there. So we have this vector where the values in each element are 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and the corresponding indices starting at 1 for those elements are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let's say we wanted to get the value at the 6th element or the number 16 out of this. We could just type x and in square brackets after the x, put the element number that we want or the index that we want, x6, which should correspond to 16. And you can do this with any element that you want. If you put in an element that's out of range, it's going to tell you an NA. So it still returns a value, but that value is going to be NA, and that doesn't create an error. In a lot of languages, that would create an error, saying index out of bounds or something like that. In R, there's no error. It just returns an NA value. Again, one of those things you have to be careful with, where R doesn't throw an error where you think maybe it should throw an error. Okay, so that's the basics of indexing with a single number. Pretty straightforward, right? Oh, also I should characterize one more thing here. It will also not return an error if you put the 0 in there for the index. That actually means something else in R about a different component of the object, that is the atomic vector that we're dealing with here. So I just want to point out that also does not return an error, and it gives something that really is not going to be meaningful if you're just looking for one of the numbers from this vector. We can talk in detail about what that is at another time. But just be aware that that 0 index doesn't give you a particular element from the vector. Now, just like all other objects in R, when you give it a single number, R is not really interpreting that as a single number. It's actually interpreting it as a vector. So what we're giving inside those square brackets isn't just a single value to R. R is saying that is an atomic vector too. And that atomic vector can actually have more than one value in it. So you can put something in that square brackets that is more than one value that will give you more elements of your vector when it returns them. multiple, and you can get multiple elements that way. So let's say I want the 5th through the 7th element. Well, I can put in a 5:7 because I know that 5:7 will create an atomic vector of integers that is going to include 5, 6, and 7. So if I hit enter, this will return a new vector with 3 elements that were the 5th, 6th, and 7th of the elements of the original x vector. And you can get any combination you want this way. Let's say we want to go the 1st through the 3rd, 11, 12, 13. Keeping in mind that the reason this works is 1:3 is returning a vector of 3 integers, and that vector of 3 integers is what's being passed as the indices that you want when you put that inside the square brackets. Well, that actually works for the other constructors for vectors we've used, like C. So if you want a discontinuous set of elements, I could say, well, I want X, and I want to put in C, and I want to have the even elements, 2, 4, 6, 8, and 10. That will give me a new vector that will have picked off the 2nd, 4th, 6th, 8th, and 10th elements, which include 12, 14, 16, 18, and 20. So this gives you all of the power of all of these different ways of indexing with vectors to get whatever combination of elements that you want. So seeing all of this junk inside those square brackets and what all could be in there, like as long as it returns a vector with numeric values that it can turn into integers and use them as indices to the different elements, it will work. And lots of people have been creative in their code and using this feature, but it really makes code that's kind of mysterious to read the first time you encounter it. So some examples we just went over is using the colon or the C operator to get a collection of elements. You can also index with vectors of logical values. So I'm going to create a shorter vector here for demonstrating this. Let's just say that y has 3 values, c, 1, 2, and 3. I can index y in square brackets with a vector of logical values where the vector needs to be the same length, and where it's true will return a value, and where it's false it will not. So in other words, let's say I want the 1st and 3rd element of this y vector. One way to get those would be to put in a C function here to aggregate things together and say I want a true, false, true. So this vector is the same length as my vector y, and I have a logical for each element of that vector. So the first element of this logical vector is true, the second one is false, and the third one is true. That means this will give me the 1st and 3rd elements of the y vector for that index, or is numbers 1 and 3. So that may not be obvious how useful that is right now, because it may seem totally unwieldy to do it that way, having to type out that C and all those trues and falses to get this. But remember, there could be a function inside those square brackets that's returning all of those trues and falses. And that's a way with R to quickly filter out particular elements that you don't want by using a function that knows how to look at the elements and decide whether to filter them out or not. And you can do that in one line of code. So it may not be real obvious why a vector of logicals is useful right now, but I just want to make sure you know that it can be done, because later on we're going to make some use of this where it'll become very clear of why this is a useful property of indexing in R. So as an example here, I showed how saying indexing C false, false, true, true, true is the same thing as 3:5. So hopefully that makes sense as well. Now, as I mentioned, the indices can be named, and you can use the names function to access the names for these indices. So when you create vectors, and I went through this briefly in the last video, you can name the indices. And one quick way to do that is, again, using the C function. So if I say Z is what is returned from the C function, and I want to name the first index value A, and the second index will be B. I'll put a value of 2 in there. Just to be clear, let me put in 11, 12, and C is equal to 13. And we went through this before. If we look at Z, now instead of having the number in square brackets, we have the actual names that we gave each of the elements of this vector in the names A, B, and C above the numbers. And we can use those names in the square brackets for the index to get a particular value. So if I say I want the B value from this vector, I could do a Z and in quotes a B, because it's a string that is providing that particular name, and I will get the second element of that vector. This will also work with getting multiple elements by creating a vector of strings, and it will give me those two elements with the names B and C as well. So again, there are so many different ways to index in R that this is really a big part of the learning curve, especially when looking at other people's code, because people get really creative with indexing to do a lot of stuff in one line in code in R. And this is some of the more cryptic material, I think, to learn.